All right, so we are going to be looking at activity 7.4. I'm going to do part 1 as a tutorial video, and that's going to give you the idea of like kind of how to do it and how to go through it. I'm also going to show you a really neat way to get things into your project folder that maybe you don't have in your project folder, because these files are something I would have to give to you to do that. But basically what we're going to do is make an assembly. So we're supposed to be reviewing this PowerPoint presentation before we begin 7.4, but if I did review this with you, it would be the third time that you have seen this exact same presentation. It is available on Schoology. It talks about how the mate, flush, angle, and insert constraints work, and how you can use those. I am not going to go through this whole presentation because, like I said, it's the third time that you would see it. If you need to review how to use any of those constraints, go onto Schoology, look under the settings for today, and you will see the PowerPoint is there. You can open it up, you can go through. Last time I did this with you, I actually put pieces together and made them flush, made them mate. I used the angle constraint to show you how you can make this side flush with this side, using the angle constraint, and how the insert works. I'm going to be doing those in the rest of this video, so I'm not going to review this PowerPoint with you at this point in time. I'm closing it. So, first thing I need to do is open Inventor, and I'm going to make a new project folder. So I'm going to go up to Projects, and click on it. There it is. I'm going to go down here to New, click on New, and it's going to be a single user project file, so I'm going to go on Next. And I'm going to call this one the Jack Lift. So once I have that name in there, I am just going to hit Next. There's nothing to do on this page, so Finish. And it should make that project file for me. It's going to take a second, so I'm going to pause. I did get a pop-up saying it doesn't exist right now, which that's why we're creating it. I think this is kind of a redundant question, but say OK. And I now have a Jack Lift, so when I say I'm done and get out of there, I will have a Jack Lift. Make sure it's checked, because that's where we're going to be working as we go through to do some work here. Next thing I want to show you is how I can get the parts that I gave to you into that folder. So I'm going to minimize this on my desktop. I have the Jack Lift file. I'll show you where that is so that you guys can get it in class, but I'm going to open that. And once I open it, there's only 3 parts here, so I'm just going to hold Shift and click on each one of them, and then do right click and say copy. So what I need to do now is I need to know where my project files are being stored. You guys know where they are on your computer, so you're going to navigate to that place. It's not going to be the same as where it is on mine, because my project files are stored in a different spot than yours. So mine are right here in this folder called School Files. There they are, and this is the Jack Lift that I just created a few minutes ago. So if I open that, I'm just going to right click again and hit paste. And there are the 3 things that I just copied and pasted in there. So I don't need that open anymore. And I don't need this one open anymore, so I'm just closing those so I don't have quite so many things open at the bottom of the screen. Now that I've done that, if I wanted to make an assembly, I am going to do that. But by the way, if I actually do go to open, there are the 3 parts that I just copied in there. They're right there. So it works out pretty good. I am not going to open any of those, so I'm just going to cancel that. What I want to do to make the Jack Lift is I'm going to make a new assembly. Once I have my new assembly, I'm going to start reading the directions. Create a new assembly file called Jack Lift. I might as well just go right up here right away and say Save As. And I'm going to not call it Assembly1, I'm going to call it Jack Lift. So I have that. And the next thing that I'm going to do according to the directions is I'm going to bring in the parts I need to make this. I'm going to start with this one that's called the base. And the reason I'm going to start with the base component is that we've set up the program so that the first thing that you pull into it is always going to be grounded. So I'm going to go up here to Place, And very similar to the log reindeer, I'm going to get the base. And when I get the base, I'm going to go down here to open. And there's my base. I'm just going to hit escape. That base component is grounded. That's why there's a little pin in there showing that it is grounded. And now I have two of them. There we go. Which that just means, like, if I go up to View and Degrees of Freedom, which I like to have the Degrees of Freedom on anyhow when I'm working in assemblies, there are no degrees of freedom. It is grounded. It is stuck. It's not going to move. That's what being grounded means, is that it can't move. So I got to grab the other two parts that I need, which are the wedge. So I'm going to open that. I'm just going to place it right there. And if you notice, there's all kinds of degrees of freedom. I am actually going to free rotate this so that it's more in the position that I want it when I go to actually use it in the file itself. So I kind of want more like that front edge down. There we go. Kind of like that. That's just going to be a little bit better for when I go to put it. And look at all the degrees of freedom. I can move it up, down, left, right. I can go wherever I want to go with that. I'm going to get the screw and put that in there as well. There it is. I'm going to say open. And there's my screw again. Not necessarily in the position. I hit escape a couple times to make the rest of that go away, by the way. I'm going to free rotate my screw so that it is also closer to the way that I want to use it, which is going to be like that. Alright, so back to the directions. Now that I have the parts I need in there, the very first direction says to use the tangent constraint. And I'm going to make this part of the screw match this part of the base. And when I do that, we should start to get some degrees of freedom disappearing. So, back to Inventor. I'm going to go up to Constrain. I'm going to use the tangent constraint. And I want it to be this part of the screw to this part of the base. And I'm going to say apply, and that's going to be good enough. I'm not going to try to do anything else because everything will fit together later, but if you notice, 1 degree of freedom just disappeared. I used to have 3 little arrows, and because I've put in a constraint, I now only have 2. And that's the goal when you're building an assembly, is you want all those degrees of freedom to kind of disappear. It's like having your sketch fully constrained. We're trying to fully constrain the parts so that they only move the way that we want them to move. The next direction tells us to do the mate constraint. And we're going to mate the back part of the base to the front edge of the screw. So, constrain, mate the back face of the plate to the front edge of the screw. There we go. And it pulled it way down there. That's fine. Because we're going to, like I said, we're going to adjust these in a moment anyhow. I'm just going to say apply. Hopefully I can still get at them in a second. Go back to my... I only have 1 arrow left, and it moves it up and down this way. See, that's what the last thing is. I can't move this any other way other than up and down. So I'm going to put it right there because that's about where I'm going to want it later. And that's what that green arrow means, is that this still has 1 degree of freedom up and down. If I try to go anywhere else, it won't do that. Moving on to the next part. Looks like I'm going to use the mate constraint to take the bottom of my wedge and put it with the top of my base. So, constrain, mate, bottom of my wedge, top of my plate. Notice the green arrow disappeared. I'm going to say apply. Go back to the directions. I actually don't like to do this one next. I'm going to constrain that base plate a little bit more first by skipping ahead and doing this one, which is they want me to flush where the front of this and the front of this are flushed, because that lines up those 2 holes a little bit better. So I'm going to use the flush constraint and do the front of this with the front of this. And that just lines them up a little bit better, so when I do that next one, it works out a little bit better. So speaking of the next one, I'm going to go back up now. Do a mate constraint with the center axis of this to the center axis of this. So those can be tricky to grab onto. Oops, did not mean to do that. That's okay. There we go. That's a pretty good view. Mate. I'm trying to grab the center axis of this. So you got to kind of work around in here a little. Start over. Mate. There it is. Click. And I want the center axis of my screw. So same thing. Kind of wiggle around in there. It is. Click. And that just made it. I'm going to hit apply. So now the screw is basically in the hole that was over there. And I think we now have this assembly the way that we want the assembly to look. I'm once again going to kind of jump ahead a little bit and go down here first and revert to the wireframe first. Then I'll do my analysis. So to do the wireframe, it's just a setting where I want to look at this. But I don't want to see all the I want to be able to like basically see through it. So under view, because I'm trying to change my view, I'm going to go to the visual style. I click the little down arrow here, and I want wireframe with hidden edges. So there you go. I can see kind of almost like it's invisible, and I can see through it. Now if I do my analysis, I'm going to turn degrees of freedom off since I'm in this view. Everything's constrained, so I don't need it anymore. But if I do my analysis now, I should be able to get a picture that's just like what's in the homework here, where it's going to show me where the interference is. So to do that, it says click on to perform interference, click on inspect. So up here I'm going to go to inspect. I'm going to click on analyze interference. I need to click on the first thing that I want to see how it's going to work, so I'm clicking that. And then my second one is actually the screw. And then I'm going to hit OK. And when I hit OK, I get this table-like thing. If you don't see the table thing, you click these little arrows and the table thing shows up. And it looks like, based on this, I had one interference. And it's highlighted the one interference is right here, so if I check that, there it is. There's my one interference. It's giving me information about it. If we were turning this in on Schoology and you were instructed to do so, take a snip using the snipping tool. Just take a snip of it and make sure when you snip it that you kind of get the majority of this here. Start from up here, get the table, get the part, get your parts list, and submit that on Schoology, and we are good.